Morning, evening, afternoon, folks. Some of you are joining us from outside India as well. We are on session 7. We're going to be doing AWS EC2 misconfigurations. And although EC2 is very widely used, one of the most widely used AWS services, we are going to cover specific misconfigurations that keep coming up in security reports that you might read. And these are the most obvious ones that you need to be aware of, be able to exploit them, and eventually do mitigation as well for your systems. Right. For folks who are joining us for the first time, my name is Riaz Walikar. I'm the founder and chief hacker at Cloud. This is a product we are building for SaaS engineers and infrastructure teams, so that they can automate the detection of assets and misconfigurations in various types of clouds that they have. Right, could be AWS, GCP, DigitalOcean, doesn't matter what. We've got support for a bunch of cloud providers, and automate the remediation bits, right, so that they can ignore the security part and go on to do the primary thing that they are tasked to do. My experience spans over a decade and a half. I've been breaking stuff since early 2006, 2007, all in the area of offensive security and all sorts of security environments, right? So wireless or cloud or Kubernetes, web, mobile, all of them. That's my Twitter and the company's Twitter as well. LinkedIn, it's far more easy to just search. Twitter is a little difficult. Multiple Riazes out there on Twitter. Anywho, folks who have been with us the last several sessions are aware already, but for the new folks, make sure that you read the online code of conduct, because this is a shared closed room session. I want all of you to be familiar with the cloud code of conduct, and so that we maintain the decorum of the room. All right. What we'll cover today, we're going to talk about EC2 the way I see it as an attacker's from an attacker's perspective, the way I see it when it exists within AWS, right? And this also, I'm also going to talk about how it interacts with other services within AWS and how that is manifested through internal AWS services. The most popular aspect of EC2 for attackers is to gain access to what is called the instance metadata service. We're going to talk, we're going to do a lot more with that, do multiple hands-on sessions with that. We're going to set up a lab for this, and the misconfiguration that we're going to cover, we're going to talk on the surface about what misconfigurations can arise in EC2 because of network setup, security groups, and things like that. And the EC2 IMDS, right, which is the instance metadata service. We're going to talk about different versions. There are 2 versions of IMDS, and what it means for services or users or attackers, and how they can traverse the IMDS, right? Eventually end with undoing the AWS changes you've got, and I've got a bunch of references at the end. Okay, again, scribbly drawings that I make using Excalidraw. This is what EC2 as a service looks like to an attacker, right? And this is based on my experience with EC2 when I'm interacting with it, as I'm trying to gain access to EC2 instance either through the service layer or through an external joining us. Yeah, sorry about that. So this is an extremely simplified attacker's view of EC2. This is not the official architecture of what EC2 looks like. There are far more components than what is shown on screen. I've not even labeled all of them. But essentially, what you have is your AWS account in which there are regions, right? Your US East 1 and other things. The AWS, there's an AWS account, and there's a above that is the partition, right? There are 6 partitions for AWS, and then there is your AWS account, which is you can operate across multiple regions. You have your in your account, you have your EC2 instance running in a particular region, right? The EC2 instance is supported by a lot of other services around it, right? And all of these services come under EC2 only, right? For example, to start in EC2, you require an AMI. It has to boot from an image. right? You require a volume, which becomes a disk on an EC2. You require a security group, which becomes the network border for your EC2 instance, preventing or allowing traffic from inside, outside, between other EC2 instances within the same subnet, same VPC thing. Right? So you have an internet user who's trying to access processes running on EC2 instance, and EC2 essentially is your virtual machine, right? Like your computer has compute, it has CPU, you have machines that can have higher GPU, you have machines that can have IPv6 addresses, right? Different based on your business use case, you can create various types of machines on AWS. All modern EC2 instances, I think there's a cutoff date after which all modern EC2 instances started having an SSM agent that is pre-deployed on these AMIs, unless you're creating an EC2 instance from an AMI in which you've removed the agent, right? If you use any of AWS approved AMIs, they will have an SSM agent, which is essentially a Linux or a Windows binary that runs as root or administrator, which interacts with the SSM service of AWS under your account, right? This is used for management of the instance itself. So for example, if you don't have the root password, you can still use the SSM agent to push commands like, hey, I want to update the machine, right? So install updates, or I want to get a shell inside the machine because I want to do administrative tasks, right? So SSM agent can be used to push and run processes and do management related stuff within EC2 instances. So there's also the IMDS instance metadata service, and we're going to talk about that a little bit more. But contrary to popular belief, instance metadata service does not run on the EC2 instance, right? A lot of content on the internet you'll see when people talk about the IMDS service, they talk about this IP address 169.254, 169.254, the magic IP address and all that. This is essentially a non-routable APIPA IP address. If you've configured Windows or Linux networking back in the day, and you have to manually configure this, an automatic IP address would be assigned to your system, right? So this belongs to that class of automated IP addressing scheme systems. So this IP address is essentially an endpoint where you can query to make or rather to fetch data about the EC2 instance, but this doesn't run on the system. There's an IMDS service that AWS has, which the hypervisor exposes, on which the EC2 instance is running, right? The only thing is when you make a request, the hypervisor detects that a request is coming to this IP address, right? And what machine is it coming from, and that IMDS is exposed to the user or the service making the request. Okay, we're going to do hands-on with this, so it will become a little more clear. The metadata service is essentially an HTTP API service accessible to on every EC2 instance, unless you've explicitly disabled the service itself while startup or later on once the machine starts. It has the following properties, right? It's reachable on a non-routable IP address, APIPA IP address, which means that you will not be able to access the IMDS service for your EC2 instance outside the EC2. If you have two EC2 instances, you will be able to access the IMDS service for EC2 instance A only from A. You have to be either on the machine, right, as an attacker using SSH or command execution or whatever, or as an administrator over SSH or any other program that you're using. You have to be present on the machine, or you must access the instance, the metadata service through another service using a vulnerability like SSRF. Right, so you make SSRF is essentially you're tricking the server into making a request on your behalf, not necessarily HTTP, but any request on your behalf. You control the target where the server is going to make the request. The IMDS stores instance related data, so a bunch of your information about what AMI, what region, your instance ID, any public keys, things like that. Also stores user data. So while booting the machine, if you have provided information to the machine, right, saying that I want these 10 commands to be run, that commands could simply be setting up an Apache server, for example. You have this all in a file and you pass this as a user data script to the EC2 instance when it is starting, when you're running run instances. The user data content is present in the IMDS, right? So you'll be able to access and see the contents of the user data that was uploaded. And this is a good pen testing, caveat also. If you've got a shell on an EC2 instance, most people try and dump IAM credentials, right? Which is what we're going to do as part of the exercise today. But also, it's useful to look at slash user data as well, so that if there's any keys that have been added, private or public keys that have been added to the system, or any credentials that have been created, or any other information that the administrators wanted for the machine, they are going to be present inside the user data script. A very important feature of, and why essentially the IMDS is really useful for services, is that it can be used to invoke the security token service, the STS, right, of AWS, so that you obtain temporary credentials, right? How do you obtain temporary credentials? A role is attached to the EC2 instance when you're starting the EC2 instance. Okay, so depending on what permissions the role has, when you generate temporary credentials from IMDS, you will have those permissions that belong to the role. So if the role has administrator access permissions, very bad idea, but people do that. And if you do an STS, assume role, you will be able to obtain the temporary credentials for the role, right? And then you can do whatever you want in other services in AWS as well. Comes in two versions, IMDS v1 and v2. Briefly talk about that. IMDS v1 is considered to be insecure because to access the service, all you have to do is a curl request, no headers required, no extra data required, right? And I've shown two URLs here. This is the endpoint. You make a curl request to 169.254 and you will see data, right? And if you want to access the metadata endpoint within, or the API route within the IMDS, you go to /latest/metadata, right? For IMDS v2, you have to generate a token. Okay, so this is how you generate a token. You pass this header, you make a put request to the /API token endpoint, and you make pass this header telling how much time you want the token to be valid. 6 hours is a prominent example on even on AWS documentation. And then you pass the token that you've received to the same endpoint, right? This is session oriented, that is not. And it's interesting because if you have a header that is passed to the instance metadata service, it is considered to be secure because when you're doing a SSRF, in a vanilla SSRF, typically the vanilla is the most basic kind of SSRF where you control only the route, right, or the URL that you're going to make the request to. And IMDS v1 would you'll be able to interact with IMDS v1 and retrieve data. But for v2 you require a header, so SSRF will be pointless here. Alright, this is what it looks like. I'll just give you the script so that you can set this up yourself, and we'll take a look at the hands-on bit from here. Okay. I'm pasting the link in chat. This is a bash script, unlike the commands that we've seen earlier. Make sure that you run Masterclass, do the get caller identity, confirm that you have the profile Masterclass up and running, and one else is joined. Yeah, so make sure that the profile Masterclass is up, and this is a bash script. So essentially you download it, you do curl or just download it using a browser, right, and run bash, bash space file name. It'll create a bunch of resources, and you should be able to, and at the end of the script it will present you with a SSH command. You should be able to SSH into the machine. The script takes about 2 to 3 minutes to get the machine up and running and print the SSH command. Let me know if you have any errors, if you see any errors when you're running the command, please. I've added comments so that it's self-explanatory. create a directory. I'm forcing it to run in set your AWS to region US East 1. Create a directory, cd into it, generate an SSH key pair, apply relevant permissions to the private key, import the private key to your US East 1 region, identify what your default VPC is, create a security group within the default VPC. This is the name, session 7G SG, and fetch your public IP address. This is important because the instance that is created has a vulnerable web application. You wouldn't want the web application to be exposed to the internet, right? So the IP address of your system, your public IP address, is what is going to be added to the security group. Okay, so port 8022 is going to be opened for your IP address, and then an EC2 instance is going to be created. Profile is going to be created first, and then an EC2 instance with that profile. I've already created the app on an AMI, exposed it publicly. So this is the machine. This is a simple for loop. There's a while loop here that checks if the machine is up. If it is up, then it will print the SSH command. You will got it? Thumbs up, thumbs down. Script is still running. Okay. I've logged in somewhere. You can confirm that the machine is up and running also while the script is running. You can go to your log into your AWS account, and in US East 1 region under EC2, you should be able to see the machine up and running. Like if you miss the public IP address, you can get it back from here. SSH into the machine command is going to be printed on screen. Okay. Done. Don't wait for me to check on you. Just do a thumbs up if you've completed deploying the machine. I've got a couple of questions after the next slide. We're going to use the setup that we have now to answer those questions. All right. Seems like a bunch of you have already created a machine. Let me know if it's stuck somewhere, because the longest time consuming command in the whole thing is the run instances command, which is the actual creation of the machine, powering it up and all that. But even then it should get done in 20-30 seconds. There are multiple ways of bringing up resources within AWS. You could do Terraform, do CloudForm. I prefer scripts when I'm teaching classes like these, essentially to get you folks to see the actual commands that AWS CLI has, including the query and filtering and other things that are useful if you're trying to identify information. Bringing up resources is one thing, but if when you're every day working with resources within AWS, these commands become a good way to practice. All right. So to the questions for this scenario, can you figure out either through the CLI or the console? I'd recommend do the console for now. What IP addresses are allowed to access port 80 on your EC2 instance? Right? You don't have to tell me the IP address because those are going to be your public IP addresses. But tell me and confirm whether it's only one IP address or there are more IP addresses that are allowed access to port 80. Do you have any IP address at all that is allowed to access port 80? Yes, no. What about port 8000?
Yeah,
Yeah,
only
only your public IP address. Great. So the same thing is valid for the SSH also. I think only your public IP address is allowed access to SSH. The second bit is to SSH to your machine and use the instance metadata service to figure out a bunch of these things. So we'll go through each one of those. Yeah, so to look at and ignore the port number here in the screenshot, but this is a generic way of answering the question. Should have been port 8000 because I updated the port number and did not update the slide. In any case, what you need to do is go to the machine under security, right? You have your security groups, right? And I've always had this I have always tried to imagine what the UI designers of Amazon would have faced the dilemma then, that should security groups, which is essentially a firewall, should it be under security or networking? Firewalls are this layer in AWS are networking equipment equivalent. Right? But in any case, you have security groups here. If you look at, you can go to the details by clicking on that, or just look at the IP address here. Right? So this is my public IP address, and what we have then is for port 8022, my IP address is allowed access. Great. So second bit is where you interact with the IMDS to answer your questions. Make a request to the IMDS to figure out the following information. What is your instance ID, your AMI ID, name of the role attached, and was any user data supplied, right? I have the answers, or rather the curl request that is supposed to make are given on screen, but I would want you folks to interact with the IMDS on your own and see what else is also available, right? Not only to answer the questions that are presented in the slide, that are asked in the slide, but also for your benefit, see what it looks like as well. So you do curl HTTP 169.254.9.4. Right? You see various versions, or rather, this is not the version of IMDS, but the version of the data within. Right? So you would want to look at the latest, where that contains the most refreshed copy of all data on IMDS. You could look at one in 2007, 2022 also. because the machine was this machine was created today, 2022, and all of these are not relevant, right, to the IMDS itself. But these are the versions of, they're not the versions of the data within IMDS, but they're versions of the query that populated the IMDS, right? Like how you have IAM policies have a version, right? That version release of that policy description was to define how the policy layout was, right? Similarly, for these, if you look at any 2007, for example, it will not have all the data that IMDS has. Quickly take a look at that as well. If I do latest, for example, you have dynamic metadata, use data. I could do metadata and have all of these pieces of information. But instead of latest, if I pick say 2007, right, and query that instead, you'll see that IMDS did not have support for a lot of you see the number of data points within IMDS is less than what it is today, right? So that's what it means, the version of the data that is retrieved to populate the IMDS. Okay, so answer your questions now. How do you figure out the instance ID? It's there under instance-id. There you go, that's my instance ID. AMI ID is also present, right? Name of the role attached. Role is an IAM property. So under IAM there are two keys. The IAM property is going to be present only if a role is attached to the EC2 instance. It is not going to be present all the time, right? So you can completely block IMDS, and then at layer 2 you can not have a role attached to an EC2 instance, in which case IAM will not be present. Okay, so IAM info gives you the instance profile name, right? And was any user data supplied to the instance at boot? Do you see that? No, 404. So there was no data that was provided. Right? Imagine a scenario where you have an application, a web application running on an EC2 instance that is supposed to write data to an S3 bucket, right, in your account itself, like an HR portal where people are uploading resumes. The application allows for a file upload, and then the file upload is sent to an S3 bucket. How does the EC2 instance have the ability to write to an S3 bucket? You obviously definitely do not want to make the S3 bucket publicly writable, right? So that the EC2 instance can write. You're then going to make everybody else also able to write to the machine, to the bucket. So to solve this, what developers, and some of you may already have be familiar with this, a lot of developers create an IAM user, all right, and they generate access key and secret the way you folks are interacting with the Masterclass profile, and add that to the code, right? Some of them write it to client, so you tend to find AWS IAM user access key and secret in JS on the client, or they will write it to the server side code, so that the server, when it receives a file and it is supposed to go write to S3, it is able to write to S3 because those IAM credentials have the ability. But you have to hard code credentials here, right? And that's always a bad practice. The alternate way is to use the credentials that IAM can generate through the instance metadata service. Okay? So under IAM, you have something called as security credentials. Right? That's the name of the role that is attached to this machine. Okay? So when I make a request now with this, if I hit enter, it will generate temporary credentials for that role. Okay? And based on the permissions that the role has, you can use the access key secret and a session token that is created to interact with other services within AWS. Okay, let's try and do that a little differently as attackers go. Imagine that you found an app, right? The HR portal, for example, and it has an SSRF in the worst case scenario. Imagine you found an app running on an EC2 instance in the wild. In your case, the app is deployed to port 8000 on your machine. So browse to the 8000 port from your systems on your public IP address. What is my public IP address? Public IP 4. There are tools available, a bunch of tools available on also, where simple scripts that simply traverse each and every route or folder or path within the IMDS and extracts the data and present it to you in readable format. But otherwise, you have to manually go through each one of these. Right? You can do a recursive wget also if you want. If you don't want to use scripts. This is my public IP address. Goes to 1000. And I'll access the app. It's a basic single form enter URL app. You all get this? Yes, no, yeah. Obviously, there are far more complicated versions of SSRF. In the references, there is a blog post that I have added where, as part of an assessment, we found SSRF in a PDF generation functionality of an assessment of a application that we were testing. So, PDF generator would make an HTML out of the URL that you would provide. So you could provide an iframe and it would go fetch IMDS for you. Yeah, but some of you must have read the article also, popular on AppSecure blog. But in any case, to get going with the exercise itself, imagine a functionality that is a complicated SSRF. Now it's all modified and simplified rather, and presented to you in this format. But at the end of the day, you need to know the endpoint that makes the request on the server side for you. You can use this to make a request to any place on the internet, right? So the request will go from your server. So I can go to IPv4. I can has right. So see, if I make the request from my browser, the IP address that I receive is my IP address, right? Now you know that this is my IP address, but if I use this form to make the request, the server is making the request on your. That's how you know that a server side request. Okay, we can abuse this definitely. Use the functionality to make request to IMDS. Find the host name of the machine. Right? How do you get the host name of the machine? You have 169.254, 169.254. Latest host name. Copy this because type it again. There you go, hostname. Generate temporary IAM credentials. Security. I need the name of my role. Fine. Just 254.1. Status. This role name. You see, it generated an access key, a secret, and a token. Okay, you need all three to be able to mimic this user that is attached, this role that is attached to the EC2 instance. Go ahead and generate those credentials. We'll all export them locally then. Anyone who's not able to access the app? Generate the credentials. Remember, once they're generated, because the response is a raw response that is being printed, there is a /n character. These are basically new lines, right? So I prefer reading the content using usource, or I usually just make a copy of this VS code and then I replace all /n with new lines. Whatever is your way of doing this, but gain the access key, the secret, and entire token. The token is a pretty long list. Make sure you copy it correctly. Done. The role name is the same for everyone. All of you have created it from the same script. Copy this code. Edit this code. Visual item. And remember, this worked because IMDS is set to version 1. Right? Actually, IMDS v2 is optional, and IMDS v1 is what system is using right now. Just because it is IMDS v1 does not mean that you can't do IMDS v2. When IMDS v2 is enabled, you can't do IMDS v1. But when IMDS v1 is enabled, you can do both IMDS v1 and v2. Right? So you can make the same request using a token also. That was done so that when they introduced IMDS v2, legacy programs wouldn't break. Right? So any new testing that developers would do, if you're moving to IMDS v2, you could move, and any other code that is on older that is using the older version of IMDS, they would also work. Okay, so I'm assuming all of you've got thumbs up, thumbs down. You obtained your access key secret. Yes, no? Okay, so if you've obtained your credentials and we're using the app to generate this so that you see that an SSRF or a web application running on an EC2 instance which either provides the functionality through say a command execution or you've obtained reverse shell, doesn't matter how, but as an attacker if you're able to execute or make a request, not execute commands necessarily, but make a request to the IMDS, you would be able to generate the security credentials if a role is attached to the machine, right? That was the point of using an app to do this instead of doing SSH. SSH you obviously have access, right? But as an attacker, imagine the web app being available to you. Okay, so this is what it will look like for you folks as well. Can you all confirm you all can see this? Thumbs up, thumbs down. Okay, so on your local system now you run these export commands. Okay, you all want me to paste this here? Pretty straightforward. So we'll go ahead and type it on our system. So now I'm on my local system. Export this. I can always do hyphen region here to change my region. Export AWS access. And if you have been paying attention since we did the IAM class, IAM credentials or access keys that are generated for a user start with AKIA, right? And any assume role credentials that you generate will start with ASIA. There are different formats. So these are the, you can quickly by looking at the key you know that this is coming from an assumed role. Export AWS secret. You can configure, but then you'll have to edit the credentials file to add the token because AWS configure does not have the option to add the session token. AWS secret access key, adding the key, right? And if I do STS now, it shouldn't work. Damn. This is my other profile. Hang on. So it didn't work, and then this came to add prove this. So I do, let me add the code AWS and okay, so the STS is still showing my default profile. What we'll do is let's configure this. This is the thing to do this. AWS configure profile stolen. Right. because I have a lot of stolen credits. So stolen credits masterclass. Ask for access key. You paste it there. Secret. Default region US East 1. Output format JSON or default. And if I do STS, the entire command AWS STS file heads masterclass. Right, so you see it made a request, but it said the security token is invalid because I didn't provide it the security token. To fix this, you have to add another line inside the credentials file, right? For obvious reasons, I'm not going to open that on screen. I'm recording this. However, what you can do is open the aws.aws/credentials file, okay, and right at the bottom where the new credentials have been added, let me add and I'll show you the tail. AWS, I'm adding that here. Keep from yeah, okay. So I just added it to. So if I do tail my file, see the profile that I just created is added here. Okay, so now I've added the session token also. All right, now access key, secret access key, and session token has been added to the file. What I can do is now if I run get caller identity with the profile that I created, it should tell me that I am authenticated. Slow. Okay, so you see this is an assumed role for the name of the role, and for this instance, that's the instance ID from where this role was obtained, the assembly credentials are obtained, right? When you do an STS for masterclass, for example, the ARN is different, right? You see it's AWS IAM, right? The service name, account name, type of principal, and name of the principal. Here in this, it is AWS STS, that is the service that generated this account, the type of principal, the role name, right? That's a name, and the name is actually this entire thing. This entire thing. Okay. Once you have these credentials, you can then go ahead and do your S3, LS, and other AWS commands. Right? You are essentially now masquerading as the EC2 instance to which that role was attached. Right? I highly encourage all of you to do this while the machines are still up. But if you find credentials in the wild, that's how you configure a new profile, right? We saw that in session 1. But if you generate a temporary credentials, or if you found temporary credentials somewhere, then update your credentials file by adding the session token at the end of the section where the new profile. All right. I thought I'll cover these two topics as bonus content for this session. The first one is actually post that I had written about machine identity. Yeah, so in the references, take a look at the last reference here. I had tried to discover what the use of a credential. Basically, there is an endpoint in IMDS that allows you to generate temporary credentials even if no role is attached to these. However, the permissions on the credentials that you've generated are very minimal. Take a look at the blog, identifying what these permissions are. Okay? So AWS has documented this to only the level that it says that these credentials are only used to identify the EC2 instance in the entire AWS. That's what AWS. That's all AWS says. Take a look at the blog to get of what the point is as well. The second bit is essentially I wanted to show you what you see on the IMDS endpoint. You run like a packet capturing utility like TCP dump, and when you make a request from another AWS service which interacts with IMDS. So any other service that is going to interact with the IMDS through AWS's network, because it's on the hypervisor. What is the what are some of the things that you can see on the service? And as I've mentioned it earlier as well, the IMDS is not only present because the user will access it or a program will access it. AWS itself uses a lot of these endpoints for internal functioning and data collection about the instance. So let me just SSH to the machine. It is a little slow. I'm running TCP dump on ETH0 interface, verbose velocity, decode application layer packet, capture full packages, and the filter is capture only packets that have either source or destination to 160 and source or destination port. TCP dump, for folks who are looking at this for the first time, is a very powerful packet capturing utility. There are a lot of tools that are built on top of TCP dump, allows you to capture all sorts of packets, literally thousands of protocols. Really good tool if you protocol level things. So I'll just run this, and while this is running, let me go trigger a service within EC2 that supposedly interaction interacts with the EC2 instances IMDS service through the hypervisor itself, because AWS doesn't have access to your machine. That would compromise data privacy, data integrity of your machine. So obviously they are able to interact with your machine. So I have the instance here, the UI. So yeah, so this is the instance. Let me just, okay, let's trigger an EC2 instance connect. EC2 instance connect is another feature of EC2 which allows you to SSH into your EC2 instance without you requiring to have added a certificate, right? Even if your machine is private, doesn't have a public IP address, the EC2 instance you can reach the EC2 instance using EC2 instance. It's a binary that's running on the machine that AWS sends instructions to, and whatever keys need to be added, the binary takes care of that. So let's just go ahead and issue a connect request, and you should see traffic coming up TCP dump interface as long as EC2 instance connect succeeds. Time. Okay, there's error. Oh, okay. So I think I know why. You go to instance work. For EC2 instance connect to work, port 22 should be reachable on all IP address, right? I know it's a drawback, but security standpoint, SSH can't essentially crack SSH. We are okay with this. So groups and edit rules. Now it's set only my IP address. That to anywhere. This is reload the page. Page. As soon as you see that, oh, do you see that? There's a flurry of activity that happens when the EC2 instance connect makes a request to internal AWS services, which in turn sends a message to the instance binary that's running, which then makes a request to the instance metadata object. You see it's trying to figure out managed keys. You see that? It's on host 16.254 and there's a metadata token. So any querying that the AWS services do internally is using IMDS 2 version 2. So in that, let me go back. All right, I mean, you can also try this. Take a look at different services within AWS. Identify. AWS doesn't necessarily document all the services in AWS. Maybe that's a go ahead and make undo your AWS changes. We've created instance in the script. If folks want to practice, then keep the machine running. But you can go ahead and delete the EC2 instance and instance role that was created and the security group that was created default. There are a bunch of blog posts that I've added as references. You can look at the Cloud Academy post on how to update Metadata version 1 to the more secure version 2. Some measures against SSRF attacks, vanilla SSRF attacks. There is also a couple of blogs from AppSeco, the ones that I spoke about briefly, where I mentioned about how we were able to find SSRF within PDF generation module and able to extract it. One. We've also written about Capital One breach, including details that a lot of blogs didn't have on the internet. And the last one is the reserved set of security in AWS. Take a look at these references. Make sure you fill the feedback. I'll paste this link in chat. So do that. Okay. Make sure that you fill this back form, please. That's all I had for today. Any questions you'll have, we can take them now. We have free trials running for out the product, so go ahead and sign up your account. Trial is free. If you don't want to onboard your accounts, there's a sandbox environment that you can sign up and just to get a look and feel of what over to you. That's our company Twitter and my Twitter as well, and that's my email if you want me. All right, that's all I had, folks. Thank you so much for your time. Have a safe weekend ahead. We'll see, hopefully I will see all of you back again next Saturday. Take care. Thank you so much.